Okay, we're going to talk a little bit about magnets now, just natural magnets. And typically natural magnets are made of iron, okay? And what we're going to do is I'm going to show you first a compass and describe how a compass works. And then I'm going to show you, we're going to look at magnetic fields, magnets and magnetic fields. Okay, so first off, I want to talk a little bit about a compass. You notice I'm standing in the middle of my room. Well, there's a reason for that. And the reason for that is I want to stand away from all the electronics, all the metal, anything that might interact with this compass. Now, the reason I'm doing that is because this compass is a magnet, okay? And this compass aligns itself. If you let it move freely, it will align itself with the Earth's magnetic field. Well, this compass moves freely because it sits on a post like a fulcrum, and it moves around that fulcrum freely as long as I hold it flat. The other thing about the compass you'll notice is that it has red paint on one of the arrows, and that specifies north. Okay, so you can see I'm standing in the middle of my room and I'm holding this compass and it's moving around freely, and it looks like north is more or less the northern wall, or this one wall of my room where my smartboard is located. Okay, that's north. Okay, so that's the magnetic north of the Earth. Okay, so this compass is aligned with that. Okay, so now I'll show you now is that if you take this, right now this compass is measuring the magnetic field of the Earth. Well, if I bring this compass, and I'm going to switch compasses to this one now, if I take this compass and I bring it into the magnetic field of a natural magnet, like this little bar magnet down here, you're going to notice that this compass will align itself with the magnetic field generated by this magnet. Okay, and what we're going to do is we're going to measure that and draw the magnetic force lines around the magnet using this compass. Okay, so let's put it down. I'm going to move it around the edges. Okay, I'm going to start here at north, and I'm going to go clockwise around it. So I'm going to draw an arrow in the direction that the north is pointing. Now, one thing about a compass is, I'm going to digress a little bit here, but I want to show you real quickly is that, if you remember from maybe junior high, you know that unlike poles on magnets attract. All magnets have two poles, a north pole and a south pole, okay? The north pole's here, this is the south pole, okay? You notice unlike poles attract, okay? South, north, okay? If I flip this, like poles repel, okay? So you can see that when I put this compass here, its south pole is attracted to its north, and its north pole is pointed outward. So this magnetic field points straight out the north, like that. Okay, and I'll highlight that more in a minute. Now, as I move it around, I'm going to move to this position. Here, the magnetic field points this way. At this position, it points this way. At this position, halfway down the magnet, it points this way. Okay? At this position, it points in. There, like that. At the bottom, it points straight in. You know, north and south attract, right? That points straight in. Then here, it also points in to the corner. We're almost done. We'll do two more. Halfway back, oh, it points back this way again. Okay, back to the corner. Oh, I'll start here. I'll stop here. Here we go. It points out. Okay, and then at the corner here, it points out. You notice they're symmetrical? I left off a couple. I'm going to put them back on. I'm going to put on this one here. And I'm going to put on this one here. I'm going to add those two. So now you can see the field force lines coming in and out of the compass, okay, or in and out of the magnet, okay? So how do we fill in, how can I draw the entire field force lines based on what I have here? Okay, how can I do that? Okay, so let's look at some real magnets and look at the forces around them and see if we can draw those, okay? So if I look at, so this is a bar magnet just like the one I've been using, except it's a lot smaller. And you can see something going on here. You see that the magnetic force is really concentrated at the poles. The force lines are concentrated at the poles. And since the force lines are close together, that means the magnetic field is the strongest. The magnetic field is the weakest where the lines are farther apart. Okay, so you can see they go out from the poles in all directions. This is the positive, or this is the north. They go out from the poles in all directions, kind of out like that. Okay, they come around kind of in a semicircular way, and then they go back in at the south. Here's a bigger magnet, and you see the same effect. You know, they go out at the north, and then come back in, go down the sides like that, and then come back in at the south. Okay, so let's try drawing that. So I'll take the magnet off. Okay, and there's what I've got. So how am I going to draw those force lines? Well, I'm going to draw this line coming out like this. I'm going to draw this line coming out like that. Line like that. This line like that. This line like that. Then I'm going to draw a line that kind of comes down and does like this one. Okay, something like that maybe. Something like that. Like that. Then I'm going to have another line coming down and do something like this. Okay, then I'm going to have them come in. Something like that. These are going to come around like that. I'm not an artist, but okay. And there we go. So you can see, woo, I kind of drew that sort of wrongly, but that's okay. Maybe like that, and like that, and like that. And then some other lines are coming out like this. And I'll use some artistic license and fill in a bit. Something like that. Okay, you notice these lines all go, so I'll switch. Okay, these lines all go out at the north. So the magnetic force lines go out at the north, like this, okay, and they come back in at the south. Okay? Okay? How about that? So, that gives you a pretty good idea of what the force lines look like around a magnet with a north pole here and a south pole there. Okay? Force lines going out at the north, wrapping around, coming back in. The force strongest at the north pole and the south pole of the magnet, and weakest on the sides. Weaker farther away because the force lines are farther apart. The farther I get from the poles and the farther I get out from the magnet, the force lines are farther apart. That means the magnetic force is less.